Hey, good afternoon, everybody. I hope everyone's having a great day, a great week. I'm Maureen Gribble here with UE Systems. I'm really excited today to dive in on our ontrak smartlube. So we've got Sean Johnson, who is one of our regional managers. Those of you in the Texas, Oklahoma, Arkansas area have probably spoken with him or worked with him. But he's really excited to share with you all about this solution that we've had out for a little over a year now. So we're kind of talking all the ways that we are reimagining bearing lubrication, and we're pretty excited about this. The folks that have implemented this at their facilities and doing some pilot programs and things like that, it seems to be something that people are really excited about and getting some really nice results. So hopefully you all can, learn a little bit more about it today and be thinking as you're listening to Sean of different applications where this might fit in at your facility. And yeah, we just hope to kind of get you jazzed up about it. So before I turn things over to Sean, just some housekeeping, typical stuff. We are going to record this, so if you have to hop out early, you can definitely catch the end of it if you want to share this with anybody, if you want to revisit it to kind of get questions answered, things like that. So we are going to record this. We'll put it up on our YouTube channel probably later today. We'll have it up there. We definitely welcome questions, so definitely don't hesitate to type those in throughout the presentation. If it feels like it's a question that I need to kind of stop Sean and get him to clarify something, I will do that during the presentation. Otherwise, of course, we'll have some Q&A time at the end. If we don't get to all of the questions, we will for sure, Sean will follow up with everybody afterwards, or the right person if it's a question about something different. We'll be sure to get you hooked up. We also have some poll questions throughout, so just try to make this interactive as best we can, knowing that we're all kind of spread out throughout the country and globe, perhaps. And of course, like we always like to say, just pardon any noise issues, dogs barking, things like that, any technical difficulties. If one of our audio drops or internet, we are doing this live, which we find a lot of value in, but of course that opens us up to potential little mishaps. So just know that we'll jump on it as quick as we can and bear with us. But with that said, I am going to turn the slides, the presentation here over to Sean. And Sean, we will let you take it away.
All right. Well, thanks again for the introduction there, Maureen. I appreciate it. But today, obviously, we're here to talk about bearing lubrication and how we reimagine bearing lubrication through the only condition-based automatic lubrication system. Let's go ahead and get started. So believe it or not, there was a study done by SKF a few years ago. Of course, there's various other studies done out there by several other bearing manufacturers, but what we found, or what they found, I should say, was that 80% of bearing failure is attributed to lubrication-related tasks. So let's go through that. So obviously, we're going to have premature bearing failures due to some things outside of bearing lubrication. However, 80% makes up a good majority of that premature bearing failure that we do see today. I mean, let's go through it. Insufficient lubricant quantity, we're at 15%. Are we getting enough grease? Maybe it's not enough grease, we don't know. Long time without renewing, okay? That's part of the using that whenever we get around to it lubrication phase. Unsuitable lubrication. So maybe we're grabbing the wrong grease and we're putting in the wrong grease type into some of these assets that require a more specific type of grease type. Lubricant contamination, 25% makes up of that premature bearing failure. These are all the things that we're focusing on using the ontrak smartlube system as the first, and again, the only automatic lubrication system. So when we think about traditional condition monitoring programs, we often think of the P to F curve or I to P to F curve. How quickly can we detect that onset of failure? So like we discussed in the last slide, 80% of bearing failures is lubrication related. Again, because it all starts with bearing lubrication, that is the area that we want to focus on so that you don't have to worry about bearing failures in the future. So let's look at the evolution of bearing lubrication, okay? And we'll start from the number 1 and work our way to 5. So on number 1, that's what we like to call the whenever method, okay? I'm sure some of you are familiar with this term, you know, whenever we get around to it, whenever we get a chance to lubricate bearings. You know, obviously we're not doing any kind of condition monitoring or using any calculation. We're just getting to it whenever. The next step up above that would be your time-based lubrications, or I'm sorry, yeah, time-based lubrication. So this is what I also like to call the assumption method. So depending on where you're at, I'm sure some of you probably use some type of calculation on some of your assets on the frequency of you going out to go lubricate a bearing. That is that time-based lubrication. Again, using some assumptions, we have to assume that we're using, we've got the correct temps, we're assuming the load, and we're assuming the RPM just to get those calculations. And if we're just assuming that, then we're really just assuming that we should lubricate these bearings on that time frequency. Taking it up, step notch up, would be the condition-based monitoring, right? So some of you, or probably the majority of you, are familiar with condition-based monitoring, especially if you're already using ultrasound. And it's very simple. We're going out there on a time base to collect data, right? To see that friction level of the bearings. And depending on the condition of that bearing, seeing that increase in friction, we will lubricate that asset at that point in time. Now, again, of course, we've got that gap in between data collection, and we're not going to be able to see if there was anything that occurred in between that data collection. So let's take it a step further. We've got automatic lubers, right? Now, you are avoiding contamination by going into the automatic lubrication. However, you're still time-based, okay? And again, you're still using that assumption method, assuming the temps, the loads, and the RPM to get that time frequency of that automatic luber. And of course, finally, the ontrak. Now, what we did with this is we combined it with ultrasound in real time with automatic greasing based on friction rather than time. So now we can say that we can monitor bearings and grease bearings from anywhere at any time. Now, when we think of the ontrak system, obviously, most of us are going to think of the box, right? That's what you've seen in the invites, the pictures. You see the box in the background. It's got the label on there that says ontrak. Well, what most people don't realize is that it's the 850 sensor, you guys see here in this picture, the 850S sensor that is the heart of the system. Well, why, you might ask? Well, that is what is actually measuring that friction. By measuring that friction, we're going to know when friction has gone up and know how much grease is required to restore that bearing back to the baseline friction level. And best of all is that we're getting those friction levels in real time. Now, without a system like this, typically we're time based on month to month, right? What we don't realize is that there is slight damage occurring every time we delay that bearing relubrication. Whether it's overgrease or undergrease, we are causing that slight damage over time. So by having the heart of the system measuring that friction level in real time, we're able to avoid that delay and potential damage over time. Now, when we look at the 850S sensor, we designed the sensor for purpose to measure those frictions, the friction levels of your bearings. Now, the sensor is a stainless steel sensor, IP67 rated for all weather. We have these sensors all the way up in northern Canada. I think, as a matter of fact, it was negative 47 degrees Fahrenheit where we've got some of these systems installed at, all the way into the southern parts of the US. The sensor has a dynamic range from 0 to 100 decibels. Of course, having that ability is going to allow us to pick up on the smallest change in friction. And if you're already a user of ultrasound, you guys are already going to know about sensitivity adjustment, right?